Right, it's Beth Mankameyer. So I want to thank everyone for joining us today. I am the product manager for Fume Hoods here at Labconco. And also, just in case, you might have a question, but we might not get to it, or you might want to talk to your health and safety folks. I've included my email address up on the screen as well, just in case any questions come up later. So please, feel free to contact me later if you think of any questions after this webinar. Alrighty, so today's discussion, we're going to be talking about chemical fume hoods. So I just wanted to start off everyone on the same page because these are the hoods that are just protecting personnel from harmful chemical fumes and vapors. So we're not talking biological safety cabinets or powder enclosures. Those would be completely different pieces of equipment. So if you're in need of some assistance on those hoods, you can always email me and I can get those to the right people. But today we're just talking about chemical fume hoods. And here's a map of what we're going to be discussing today. So under the umbrella term of fume hoods, we have ducted and ductless hoods, and we're going to be exploring the different types of hoods that go under these terms. And it's really no surprise that people need training on this subject. I'm showing this slide to illustrate how many hoods are in the two categories that we're going to be talking about. And each of these hoods is appropriate for a different reason. So this webinar is going to help you navigate that first step. If you're needing to purchase a fume hood, this is the first step deciding whether you need to go ducted or ductless. So going back to our map from before, first we're going to dig into ducted hoods and then explore what kind of costs you can expect with that ducted system and what type of systems are available, like what you see up here. So then we're going to go into ductless, and then we're going to come together and find out which would be better in what applications and why. And that'll help you choose what will be best for your lab. So this is the most common type of duct layout, starting out with that ducted. So it's a remote blower configuration. And in this image, starting with the hood at the bottom there and moving up, we have the ductwork connection on top of the hood. And then we have a 90-degree elbow, since the inlet to the fan is actually on the side of the fan there. So that's why we have to have at least one 90-degree turn. And then we have the remote blower that's located most often on the rooftop or an attic space, basically some unoccupied interstitial space that has enough ventilation for that blower. And then we have a vertical outlet that has a zero pressure weather cap as the termination, like what you see here. These blowers have to be sized for the duct run, and this is the layout that you'll see for most installations. So the air that's going through that fume hood is completely controlled by that exhaust fan. So if you have a constant volume system where air is being exhausted, where the air that is being exhausted through the hood is the same amount regardless of your sash position. So if you're exhausting 1,000 CFM with the sash open and then you close the sash, and it's still going to exhaust 1,000 CFM. That's what a constant volume system is. That blower doesn't change RPM, and if you have a variable volume system, that's when the air being exhausted through the hood is different depending on the sash position. So you might exhaust 1,000 CFM with the sash open, and then that might drop to 200 or 300 CFM when the sash is closed. Then that means that the fan either changes RPM or that there's valves in the system that talk to each other and keep the supply and the exhaust air in the room in balance. So one blower can operate more than one fume hood on this type of configuration. And that's kind of the beauty of this configuration. You can size the blower for whatever the hood and the duct run need. So the reason this is the most popular installation is because all of the ductwork is kept under negative pressure, meaning if you were to get a leak in the duct run between the hood and the blower, and let's say that ductwork goes through an office space, that, you know, something that has nothing to do with what's going on inside the hood, then the fan will just suck that air through the leak, not allowing the harmful vapors out of the leak. So this is what a typical rooftop installation looks like with a remote blower. The ductwork goes into the inlet of the blower on the side there, and then you have the zero pressure weather cap on top to allow the air to exhaust vertically and be taken away and diluted. So this is kind of the one hood, one blower. Obviously, it gets more sophisticated with this. If you have a bunch of different hoods, you can have a very sophisticated manifolded system, but this is just the base kind of to compare on the base level. Because now we're going to look at the built-in blower configuration, where the blower is sitting right on top of the fume hood and it's actually pushing the air up. So going back to the previous one, this one's pushing the air up, the other was pulling the air from the exhaust fan location on the rooftop. So that's the difference. This duct run can go directly vertical, but on this version, you can't size the blower. The blower is built, it's built into the top of the hood, so you need to make sure your duct run is appropriate for that blower's fan curve. And so, you know, whenever you look at these, the manufacturer is going to have a certain maximum amount of duct that you can have on this system, because every time you add that duct, that's what's adding static pressure or resistance to that duct run. So the fan can only overcome a certain amount of extra resistance. So these setups, they're typically louder because the fan is right on top of the hood. So I wouldn't recommend this type for any kind of teaching lab, any lab where noise is a factor. And the biggest reason against using a built-in blower is that it puts all of the ductwork under positive pressure. So the entire length of duct from the fume hood up to the termination, basically up on the rooftop, it's having air pushed through it rather than being pulled. And so going back to that example in the office space, if you had a leak, it's going to just send that contaminated air through that leak because it's under positive pressure. So I always say to start with the remote blower configuration, and if you can't make that work and you have a short, straight duct run, then you can go with the built-in blower. Because this kind of setup, it's ideal for mobile lab spaces or single-story buildings with a pitched roof, where it would be really difficult to install a blower on the rooftop. So the typical costs associated with a ducted system, of course, they have to do with the duct and ducting that hood out. So the actual equipment this would be the actual equipment and energy usage costs. So the upfront costs are the hood, the ductwork, the exhaust fan, and the extra tonnage required to air condition the air that you'll be sending outside, because you have to add more air into the space to duct it outside. And then the installation, which could mean putting holes in your walls and a roof, and all of that can really be costly. So this is just to put some numbers to what we're talking about. You can plan to spend about $10,000 on a typical 6-foot fume hood assembly. And then added on to that is your infrastructure. So your blower, your ductwork, your air handling units, installation. I put a starting value of $20,000. Honestly, that's probably pretty low, but I've seen upwards of $50,000 for a tricky building. And then if you put sophisticated controls on it, then it would be upwards of $100,000. So this number is extremely variable. And it would be on a case-by-case basis, whether, you know, what that number would be. Because some buildings, think about it, if you already have your duct run, if you're doing a retrofit or you're replacing your fume hood, if you already have the duct run already installed, you can save a lot of that money. So that's kind of on the other side of the coin. And these are the startup costs. So one way to lower the number is to use a high-performance hood that doesn't require as much CFM as a typical hood. And so the high performance hood, it's a total different topic in itself. So to keep it simple, I'll just say that the lower the CFM, the lower your upfront bill and the lower your annual bill. So if you can lower your CFM, which is the cubic feet per minute of air that's being exhausted out of the ducted hood. So energy costs are going to vary depending on where you live. the folks in the Northeast have higher bills than in the Midwest where we are. We're in Kansas City here. So typically we estimate for our area like $8 per CFM per year. You know, in the more expensive areas, it'd be more like 13. I don't know, it might even get higher than that. But just to give an example, on a typical 6-foot hood, it's going to be about $5,000 to $9,000 per year. And so that cost is attributed to you're air conditioning the air to go into the lab, and then you're exhausting it out. So that's that extra air that you're air conditioning to be able to actually use your fume hood and have it contained. So if you're looking to save this money and you're using a ducted hood, here's some other figures to help illustrate what you can do or what decisions you can make in order to lower that annual bill. So just switching to a high performance hood can reduce your air consumption by 40 to 60%. So if you're on the market for a hood and you are going ducted, I would definitely, the amount of hoods that are offered today that are high performance, it's most of them, I would say, at least from Labconco. So I would say definitely switch to a high performance hood if you're using that hood regularly. Using a variable air volume hood or a VAV hood, and that's where the amount of air that's being exhausted changes as the sash goes up and down, you can lower your air consumption by 10 to 75%. And you're probably looking at this going, wow, that's a really big range, 10 to 75%. Because in order to be effective, the sash has to be lowered on a VAV system. If it's never closed, then you never see a change in air being exhausted. So it would act just like a constant volume hood if you never change the sash position. So that brings us to the best case scenario, using a high performance hood that is on a VAV system and has sash intelligence. So what that means is the hood has a motion sensor to detect a person's presence. And if the sensor doesn't detect motion, then the sash will shut. And that's when you'll reap the benefits of the lower CFM. So these can save at least 90% of the required air consumption compared to a standard fume hood at a constant volume. So it's quite significant there in the change. But once again, the real fact that we're looking at here is the lower the CFM, the lower the energy bill. So if you are going ducted, look at that CFM number compared. That's what you can compare from hood to hood, manufacturer to manufacturer, and make sure that you're getting the least amount of CFM. So explosion proof, once again, this is a topic that could probably be its own webinar, but the bottom line is if you need an EP hood, it must be ducted. So that's kind of just the rule that we're going to go with on this webinar. If you have any other questions on that, please email me. Like I said, it's a whole topic in itself. So here we are back on our map. We're going to talk about ductless hoods now, and we'll go over the cost implications and the definitions and considerations when choosing what type of hood to use. So here's just a photo of one of our ductless hoods. So you might be wondering what a dinosaur has to do with ductless hoods. This is an image of the Denver Museum of Nature and Science, where they actually have a specimen curation lab directly under this dinosaur exhibit. So this is illustrating our first reason why you might want a ductless hood. You might really not be able to put some ductwork through the dinosaur. And so they were kind of forced in that position to have a ductless hood. So we'll get into some more applications later, but basically these ductless hoods get their name because of a carbon filter pack that's located above the fume hood that cleans the air before recirculating it back into the lab. So they require no ductwork, just like their name says, ductless. So you may think, hey, perfect, that sounds easy, let's do it. Sounds cheap. Well, we'll learn about the reasons why you would and wouldn't want to use these in your lab in these following slides coming up, starting with the definitions given by SEFA, who is the Scientific Equipment and Furniture Association. They are the people who have defined what the SEFA definition for ductless hoods. So the DH1 hoods are for nuisance vapors. So DH stands for ductless hood, and we're going to have 3 different kinds. So this is starting with DH1. These are for the nuisance vapors or non-hazardous chemistry. So these are typically smaller enclosures and they don't have sensors built into them as a standard item. So the way you tell when how to change the filters out, you use your nose, basically. If it starts smelling, then that's when you change the filters out. So obviously you don't want to use anything hazardous. These enclosures will have application-specific filters, so like ammonia or formaldehyde or organic vapor filters. And so typically the typical applications for these are cover slipping or staining, like what's shown up in these photos, or things that you might do on an open bench that would be smelly. So from Labconco, the enclosures that we have that are DH1s are called the Fume Absorber and the Protector Workstation. So after every one of these definitions, I'm going to give a quick rundown just to put it all in a nutshell. So the quick rundown for the DH1 is it's for nuisance vapors. There isn't a sensor as a standard, and these are for applications you could do on an open bench. So now moving on to the DH2. The DH2 does have a sensor on top of the filter stack. So it does have the safety feature of a sensor. However, because it's on top of the filter stack, once that sensor goes off, the filters need to be replaced immediately. So the DH2 enclosures also have application-specific filters, just like the DH1 hood, where it would have, you know, the formaldehyde, ammonia, organic vapor. They have acid sulfur, a couple different types of filters. And since these have a sensor on top of the filters, they're really best for repeatable processes when you can tell how long the filters are going to last. So when you use the exact same amount of chemical for the exact same duration all day, every week, you're going to know how long those filters are going to last. So you'll be prepared to replace those when the sensor goes off. So if there's a limited use application that's repeatable and you don't need service fixtures or electrical outlets, then this is really the perfect hood for you. At Labconco, we call this the paramount. The DH2 is the paramount. So here's in a nutshell. They're great for repeatable processes. They have the sensor located above the filters, and they use chemical-specific filters. So finally, this is the last definition, the DH3. And so at Labconco, this is a marriage of products between Labconco and Lab using their green fume hood technology. So we refer to this as a filtered fume hood. If you ever hear ductless hoods and filtered hoods, so we refer to these as filtered fume hoods to differentiate, because this specific product that Labconco offers is so different from other classes, the DH1 and the DH2. So this hood actually has a sensor in between the primary and the secondary filter. So when the sensor goes off, you actually have an entire backup filter that's the same size and efficacy as the primary filter. So size-wise, the hood and filters are actually larger too. Each filter is about 3 times the size of a DH1 and DH2 filter. So just by sheer volume, these filters have more carbon, and therefore the filters will last longer. This hood has corner posts, as you can see, so you can install service fixtures and electrical duplexes. So it's as close as you can get to being a general chemistry fume hood without ducting out. And it also has a fully functioning sash that slides up and down, unlike the other enclosures that have a sash that lifts towards the user like a hatchback. And these hoods only require one type of filter. So this is very different from the other hoods. The other families have chemical-specific filters. This hood only requires one type of filter called a Nutridyne filter. It's still a carbon filter, but it's activated differently, and it's able to filter out acids, bases, and solvents at the same time. So the final difference for the DH3 hood is that it actually has a control board attached to the face that tracks everything from sash position, fan speed, alarms, what user, and that's based upon RFID cards provided with the hood. So overall, these hoods are much more sophisticated, but with that sophistication comes comes more user responsibilities. So we'll get into that in more detail. But Labconco's hoods that fall under the DH3 category, they are called the Echo and the Aero filtered fume hood. So back to in a nutshell, it's the closest hood, for the DH3s, it's the closest hood to a general chemistry hood without being ducted out, since it can filter out the acids, bases, and solvents at the same time, and it can have service fixtures and electrical duplexes on the corner posts. It has a sensor located between the filters, so you have a full backup filter, and it does have the corner posts for fixtures, just like a general chemistry hood. So something that applies to all of the types of ductless hoods that we just learned about is that there are some bad actors when it comes to chemical compatibility with carbon filters. And they aren't ones that are considered extremely hazardous, because a lot of times when I get these phone calls about, oh, I'd like to go ductless, I'm not working with anything too terrible, I say, you know, sometimes that's not even a concern, because some chemicals that people work with on an open bench actually provide the problem. So the low molecular weight solvents that aren't good for the carbon filtration, because they have very low filter capacities, are these four. It's acetone, ethanol, methanol, and acetonitrile. So anytime, you know, people that come to me and they say, oh, I have a cleaning application, we clean with acetone, I say that's probably not going to work in a ductless hood, because you're using high volumes of acetone, and that's going to fill up these filters very quickly, and it just won't make sense. So if you're working with these in limited quantities, or you can close the container most of the time, it still might work. But if you come to me with an application that is heavy on any of these four, it's going to get kicked out. It won't be able to be used for any carbon filtration. And so no ductless fume hood can capture every chemical. So before you can consider one of these hoods, you have to fill out a chemical assessment form to make sure the application is compatible with the filtration. This is always step one in the process. And this form is going to ask for things like the type of handling, chemical name, type of container, whether it's opened or closed, the dilution percentage, the temperature, handling frequency, quantity, duration of use, all sorts of fun things. So when we're looking at the lifetime use of the hood, you know, you have to take into account if an application is going to change. You would have to resubmit a chemical assessment form if the application does change, and because the manufacturer will be able to then tell you if it's appropriate and how long the filters are going to last. So this is always step one, and basically this has to be done regardless of manufacturer. If you go to any manufacturer with ductless hoods, they will make you fill out a chemical assessment form. So that's kind of step one. If you are interested in a ductless hood, you have to be prepared to give very detailed information on the application. And if you come back to me and say, well, it's going to change every day, we're going to tell you it's not going to be good for a ductless hood. So the maintenance conversation, it's always an important one with any type of carbon filtered hood, because the maintenance is inevitable on these hoods. People are mostly used to working with ducted hoods, where they may never have to touch anything in order to work with the hood. So they're all pretty much set it and forget it. But on a ductless hood, there will be alarms that are not typical on a ducted fume hood. So the lab personnel need to be properly trained on what to do in the event of that alarm. And someone at the facility or a pre-planned third-party company needs to be able to service that hood and perform filter changes. And then even on a DH3 hood, there's an acid sensor change out that needs to be done every 2 years. So there is maintenance, much more maintenance than what is involved on a ducted hood. So filters have a cost and a maintenance requirement, like we just spoke about. Depending on what type of ductless hood you have, the filters could range anywhere from a couple $100 to $1,000 each. And each hood can have anywhere from 2 to 10 filters. So if you look at that, the most that you're going to be spending basically on a hood would be that 10 times $1,000. So you could be spending $10,000 just on filters. This has to be part of your cost and benefit analysis when you're looking at whether to go ducted or ductless. So based on how many times you change them, which you're going to find out with the chemical assessment form, and figuring out who at your facility will do this, or if you need to outsource it. Additionally, the filters might be considered hazardous waste, so that'll have to be taken into consideration as well with the cost. With a DH1 or 2, best case scenario, I would estimate filters lasting about 6 months, and with a DH3, the filters may last up to 2 years. Those are kind of the maximum amounts that we've seen. Obviously, applications change that drastically, so those are kind of the maximum numbers that we see. The costs associated with a ductless hood include the first costs, which have a very large range because the DH3 can do much more than a DH1. So the range, for purposes of comparing with a fume hood, start at $10,000 and go up to about $30,000 for the hood alone. Then we have the filters, which could range from $500 to $10,000 per hood. But you don't have to include building infrastructure because you don't have to cut any holes or install a blower on the rooftop. But installation may cost more for one of these hoods, the installation of the actual hood, because there's filters and modules to unpack and actually install, and that wouldn't be included on a typical fume hood setup. So just to kind of illustrate, this photo here shows a pallet of 16 filters. And so when you're looking at installation, keep in mind the opening of all of these individual boxes and then disposing of them and then organizing them to be installed. It all adds additional time and labor. And you'll want to make sure that the trades know what is in their scope, so the full installation is included. Because some contractors might just see fume hood installation, and then they might take that to mean placing the fume hood in its place. A lot of people just think of fume hood installation. You set the fume hood, and then the mechanical contractor is going to come in and connect the ductwork. And that doesn't include the whole package. And that means that your fume hood could be left half installed. So that's something that definitely needs to be considered when looking at bids and what the contractor is going to be doing. The annual costs are going to be $0 for energy costs because you're not sending any room air outside. So you really only have to worry about the power to plug the hood in, which is very minimal compared to your air conditioning costs. So then the real cost, the annual costs really depend on just the filters. How often do they need to be changed? And that's always the golden question, and you have to have a chemical assessment form filled out in order to find out that answer. So we estimate the filter cost to be $600 to $5,000 annually. So quite a range, yes, but we can narrow that down if you give us your application. Disposal would also be included in that cost, which is not included in the $600 to $5,000. So whatever that would cost on top. And then any other costs associated would be from maintenance, which would be the labor to perform any filter changes or sensor changes on the DH3, and then recommission the hoods after all of those are done. So it's definitely not something that is minimal. You have to take into account annual costs with a ductless hood as well as a ducted hood. So your typical hood, a typical ducted hood, has a minimal maintenance after it's installed. We've established that. The infrastructure and remote blower may take some extra effort, but once they're set, you won't need to think about them for a while. So with a ductless hood, the user has to be trained to know what to do for different error codes. And there needs to be a backup plan in place for when the filters need to be changed on a ductless hood, because that hood is going to be down. You can't be using it when you're changing the filters out. And then you have to have the maintenance of the filter change out. So also with a ducted hood, the user can be a little more lenient with the chemicals used. You don't have to worry about filling up filters or not being able to use the chemicals in a ducted hood. The worst that can really happen is You know, you can corrode your fume hood liner and you'd have to replace it, but that won't happen overnight. You'd have plenty of warning before that would need to happen. So you wouldn't have to worry about your filter having breakthrough and possibly stopping the work before it's complete. So as long as on the ducted hood, as long as the blower is going, the fume hood is going to be doing its job. So a ducted fume hood can act as a laboratory exhaust to meet minimum air changes per hour. So let me kind of explain this. The air changes per hour, every building, even your office space, any kind of building, even your house, there's minimum air change rate that a organization called ASHRAE calls out. Labs require a little bit more than your standard office space because they take into account the fact you're working with chemicals and things that you don't want to be breathing in. So adding a ductless hood is not going to contribute to that air exchange rate, right? Because it's not sending air out. The air changes take into account how much air is supplied to the room and how much air is exhausted from the room. So that exhaust is going to have to come from another source if you don't have any other fume hoods in that room. So there's just general exhaust, and that's probably what it would have to be, what would probably have to be used. So if your intent is to save money, look to see if your minimum air changes are met first, because you may have to exhaust out anyway. So this slide just kind of shows, you know, the ducted hoods are good for these things, but the ducted hoods do require the infrastructure, the makeup air, the remote blower. So this is kind of things to consider. And the photos here show a really good ducted installation. So you've got the hoods kind of lined up in a row, and then the remote blowers on the rooftop. That's actually the same installation. So you see the blowers that are connected to the hood underneath them, basically. So now we're going to go through different questions to consider when we're looking at both ducted and ductless hoods. And we'll find out by going through these which enclosure is going to be better for what application. So first, is the general application good for a ductless hood? Has the manufacturer told you, reviewed your application and told you it's good to go? So any manufacturer who offers ductless fume hoods is going to be able to review the application and tell you if it's approved and how long they expect the filters to last. So that, like I said before, step one is always filling out the chemical assessment form. Second question is, how often do filters need to be replaced? Once again, the manufacturer will tell you this after you fill out your chemical assessment form. But if it's a short filter life, is it even worth the cost of changing those filters out versus the installation and energy cost? So you have to weigh that on a case-by-case basis. Does your room have a sufficient air gap? This is something that gets overlooked with ductless hoods. So on a ductless hood, there needs to be a 4-inch air gap above the filters, because that air is going through the filters and being recirculated into the room. Some people want to shove the hood up against their ceiling and they wonder why the hood isn't working. That air needs some place to go. So this includes any type of, sometimes people have accessory HEPA filters for nuisance particulates on these hoods. So it includes that. You'd have to be 4 inches above that HEPA filter. So if you need to double check, call a manufacturer, have someone double check, because if you don't have this air gap, the hood is actually not going to work effectively at all. So it would be like having no hood. Do you rent or own the space? This is probably an obvious one, but if you don't own the space, maybe you can't put a hole in your rooftop, and then obviously you would be looking at ductless hoods. But that's something to consider. Can you put holes in your walls and rooftop? Do you want to vent chemical storage under the hood? This is something that gets overlooked when people either assume that they can vent things into the hood. You can really, the only option for venting with ductless hoods is your acid cabinet into a DH3. So you can't do it into a DH2 or DH1. And you have to think it contributes to the filter loading. So if you want to vent acid or solvent cabinets through any hood, you would have to do it with a ducted hood if you wanted to vent out a solvent cabinet. And like I said, the only way to vent an acid cabinet is through a DH3. This is because, so you can actually vent an acid cabinet through a fume hood, but with the solvent cabinets, you cannot vent a solvent cabinet into a fume hood. It has to be attached to negatively pressured ductwork above the fume hood. And here's an image of how these cabinets vent into the fume hood. So if you are ducting out, you can vent a solvent cabinet connected to the ductwork above. Once again, this has to be negatively pressured duct, so it has to be with the remote blower setup, not a built-in blower setup. And the acid cabinet on the left shows how those are vented in the fume hood with a connection through the work surface. So you can do that with a DH3 or any ducted hood, and then the one on the right, the solvent cabinet, has to be ducted with a remote blower. So here, we have more considerations. Who is going to install the hood? If you have a ductless hood, make sure your installer scope includes more than just placing the hood on the work surface. Tell them that they will have to install the components above the hood, which includes stacking the filters and light and fan boxes on the DH3. And it includes unpacking everything that needs to be stacked and also commissioning after it's installed. And then we'll need to budget extra time for all of that, and then troubleshooting if there are issues. For a ducted hood, they're most likely covered by different trades. A mechanical contractor usually does the duct work, and you may have a different trade put that hood in place. So it's usually a lot less complicated with a ducted installation. Who's going to change the filters? The manufacturer does not come out and do this, and this is true for the other manufacturers that offer these hoods. So this has to be something. It's kind of like you know, any maintenance on your car. You have to go to a service department. So you'd have to find somebody that would be able to service this, whether it be someone at your facility or a third party. Basically, just plan ahead and know who it's going to be. This is something that gets overlooked so much. Can the hood fit through the doorway? And this applies to both your ducted and ductless, but I did want to focus here on the typical DH3 filtered hood. It has that control box on the front, and it's 43 inches deep. And it can be disassembled to fit, but once again, installation and labor, you have to plan for disassembly to put it in the room. So just keep in mind your doorways. Where does the hood have to go in order to actually get to your lab to be installed? So here's the last slide of considerations. Are you aware of the maintenance that's required? I know it's a common theme, but I often find that people aren't aware, and then they're unhappy when they aren't aware, and we just really don't like unhappy customers. We want people to know what they're getting into. So I really try and make this clear. Do you need an explosion-proof hood? If so, you have to go ducted. So that decision is going to be made for you. There's no explosion-proof ductless hoods on the market, period. It's not offered. Is this your only hood in the lab? If so, I strongly suggest going ducted. The reason why, it's going to contribute to your air exchange rate, which it's about 6 to 12 air changes per hour, called out by ASHRAE for a lab. And you don't have to worry about being so super careful with what you put in the hood. You know, there's a lot of reasons why, if it's the only hood in the lab, it would really be beneficial if you went ducted, because then what happens if a year later your application changes and guess what? It's not compatible with a ductless hood. Then you're left where you started. Okay, next question. Are you replacing your fume hood and you already have a duct run stubbed out? So as I kind of mentioned before, a lot of the costs that are associated with ducted hoods have to do with installing the duct. So if you already have a duct installed, you've won half the battle. You can just hook up a new hood to it, and I would recommend ducted for sure. Are you relocating soon? If so, you might want to consider ductless because they are easier to transport to different labs. So there is kind of a trend going on with places that are renovating their labs. So and these are labs with many, many fume hoods. But during the renovation, people have been setting up these temporary trailers and putting fume hoods in, the ductless fume hoods in the temporary trailers. And then when they're renovating the lab, they're putting ducted hoods in and then bringing in the ductless hoods along with it. So they're using a mixture of ducted and ductless, and it's helping their lab stay in operation during the renovation. And then when they get back in their permanent lab, they're using half of the air. So it's a win-win. And lastly, are people in your lab educated to know what they can't use in a specific hood? Because if you have a facility with a lot of turnover or it's hard to train people, it's going to be hard. I'm just going to tell you, if you have a stable workforce and they're highly trained or they can be highly trained, then ductless is definitely an option. But if you have high turnover and it's hard to keep people educated on the equipment, then I do suggest ducted. Okay, so more kind of pros and cons here. Ductless hoods are very flexible. Like we've mentioned, if you're going to move or you want to use the hood in a different lab space, they can be moved since they aren't connected to ductwork. So also they're turnkey, meaning they have lower installation costs for the most part, where you don't have to include the ductwork and all of the infrastructure. They're also portable and they're sustainable since they use less energy. You don't have to take all that air-conditioned air out of a lab to use them. They're green. They aren't sending chemical fumes outside. They're trapping them in a filter. And so now for the cons, they can be noisy because the fan modules are right above the fume hood. And maintenance is inevitable. There are limited applications that can be used with them. And there is actually a risk of chemical exposure with the DH1 and even a DH3 if you go through that backup filter. And then lastly, training, there has to be training in order to have a successful implementation of these ductless hoods in your lab. So here are the scenarios when you absolutely want to use ducted hoods. This would be any specialty application with perchloric acid, acid digestion, hydrofluoric, any of those go with ducted, because you not only have to use ducted, you're probably going to have to use a special ducted hood. And if you need explosion-proof construction, you have to go ducted. If you want a low maintenance hood, obviously that's going to be the set it and forget it ducted. And if you're working, this is one that comes up with high school labs actually, where you're working with highly exothermic reactions. So something that's very smoky. There's an experiment that has to do with sulfuric acid and sugar, and it creates a lot of smoke. Those would be terrible for ductless hoods. So you definitely want ducted for that. And the rest are just specific chemicals you don't want to use that include, mercury, insecticides, hydrogen cyanide, and then the acetone, ethanol, methanol, and acetonitrile in high volumes. So here are the times when it's completely acceptable to go ductless. If you have a repeated protocol with a little variation in what you're doing and what you'll be doing in the future as well, you want to take into account the future. When installing ductwork is simply not feasible. Maybe you don't own your own space, or you may be in a basement of a 15-story building. All of those scenarios, you wouldn't be able to really install ductwork very easily. If the lab already has a ducted fume hood but requires additional workspace, that's a perfect application for a ductless hood. If the lab works with non-hazardous chemicals or the chemicals are used in non-hazardous quantities or concentrations, that's a good application. If the lab needs to be mobile, like moving in the near future, renovations, temporary spaces, any of those type of things, it would benefit you to go ductless because they're easier to move. And then the last item, when training is available. So for this is the last slide, and we're just going to try and sum it up in this decision tree, basically. We aren't working with biological samples, so we know we're in a fume hood. And then if you don't have any specialty hood applications, which came up the perchloric acid, hydrofluoric acid, acid digestion, or radioisotopes, those all have to be ducted. So if we aren't working with those and we want to save money and we can't duct out, then that is basically what we're looking at along with these considerations. So I really hope you've enjoyed this webinar and hopefully learned a thing or two. But if you have any questions, send them in. Like Kylie said, we can do the Q&A or the chat. And if you don't have time today, email me, bethm@labconco.com. But I really just want to thank you for spending some of your valuable time with me. I really hope you're able to take some of this knowledge and apply it to your lab. So I know there's a couple questions here. Let me check these out really quick. Let's see. Okay, first question I see on the chat is, to go the route of variable air volume hood, what is being held constant? Constant face velocity. Yes, typically with the variable air volume hood, the face velocity is constant. So basically, you'd have 100 feet per minute, about, if that's what your facility specifies, you might have 100 feet per minute with the sash fully open, and then closing it, you'd have 100 feet per minute at 50% open and then at 25% open. So it would be a constant face velocity. Okay, another question I see on this chat is, I see acetone is a bad actor. Is there a threshold at which this starts being a bad actor? So to put this just kind of in general terms, if you're using it on a regular basis in volumes over maybe like 100 milliliters, I want to say, it would be over. Acetone starts being a bad actor at very low volumes. I'll put it that way. So any type of regular application is most likely going to get thrown out with a ductless fume hood. But like I always say, we can always check out your application and make that determination based on temperature, volume, duration of use, all of those variables into one. So very general answer to kind of a question that needs specifics. And then the last question I see on this chat here, it's, don't the ductless hoods have self-contained blowers? How can the energy cost be zero? Okay, so the ductless hoods do have little fan modules. So yes, there is an energy cost, but the reason I say zero is because you're looking at maybe $200 a year, if that, versus thousands of dollars a year when you're ducting out. So in my opinion, it's so minimal that I put $0 when you're comparing the two. Because honestly, there's going to be other things. If you're looking at a true cost scenario and you would need to put a couple $100 in there for the ducted hood, for the ductless hoods, then you can absolutely do that. But it's nothing compared to the, $9,000 of a ducted fume hood. So that is why I did put $0. But yes, thank you for pointing out there would be energy consumed for sure, because you have a light, you have a little fan module, you have these different things that will consume electricity there. So does anyone else have any other questions? Let me look in the Q&A. I don't see any there.
Beth, this is Kylie here. I think that's it. I think we got all of them. So thank you again to everybody that joined. Beth, that was a fantastic webinar. Lots of great questions going on and lots of great insights. So I'm going to follow up with everybody. You will receive a recording of this webinar. So in case you want to review anything, you will have a copy of that. And then I'll also include Beth's contact information on there, just like she had on the beginning of the slides. So thank you again, everyone, for joining us, and hope you have a great rest of your day.